Hello, problem number 546, remove boxes. So in this problem, we are given several boxes with different colors represented by a different positive number. We may experience several rounds to remove boxes until there is no box left. Each time we can choose some continuous boxes with same color that is composed of k boxes. Remove them and get k plus k. So here one thing they have given, we can choose some continuous boxes in the same color. And using this, we need to find out the maximum points we can get. So let's understand the problem first. So here, suppose we are given something like this: 1, 4, 5, 1, 3, and 1. So what they're asking, and another example can be 1, 3, 3, 2, 3, 1. So if the continuous boxes are of the same color, then we can remove both of them, and what we will get by removing both of them will be the length, that is the length is 2 here, so 2 to the square 4, like this. And if there is a single box, like if you see here, this is single 2, 3, then we need to remove it individually. So here cost for removing this box is 1 square, and the cost for removing this square is 1 square again, like this. So like this, we need to remove the boxes, and we need to find the maximum what we can get. So like suppose again 1, 4, 5, 1 there, 3 there, again 1 is there. Like suppose this is our use case. So one possibility can be we will remove the boxes one by one, right? So here if we remove one by one, then first we will remove one. So the cost of removing it will be 1 square plus 1 square plus 1 square, right? 1 square, 1 square, and 1 square. So it will be around 6. Another possible way, since they have given, we can remove the same continuous boxes, right? So if we see here, if we remove these two, then what will happen? These two one will come in continuously, right? And remaining array will be something like this. If we are removing this one individually, so here we can see by removing this one we are getting 1, and by removing this one we are getting 1, right? So if we make, the count will be 2 only for this. But anyhow, if we remove these two boxes, then for removing these two one, the count will be 2 square. That will be 4, which is greater than 2, right? And here we need to maximize our score, right? So obviously, like this approach will give us the better answer. I mean, there is a chance that this approach will give us the maximum rather than individually removing each boxes one by one. So if we see again 1, 4, 5, 1, 3, 1. So what we can do, we can find where this one is matching here, right? And in between we can remove it and can find the score of this. What will be the cost of removing these boxes? So the cost of removing this will be 2, right? Because 4, 5, 2, 1 square plus 1 square. So what we will get? We'll get something like 1, 1, 3, 1, right? And again, if we see again here, if we remove this one here only, directly suppose, then we will get 2 square, right? And remaining will cost us 3, will remove 1 square, and again we will remove 1, 1, then 1 square, then it will be 4 to 6. But if we if we don't remove this one at this point, instead we remove this 3, then the cost will be 1 square, and what will we get remaining? 1, 1, 1. So we will get 3 length, right? So the cost will be 9, 3 square. 9. So the total cost will be in this case this 9 plus this 1 and plus this 2. 2 will get from here. So 12, right, which is more than all of this. So what we saw here, like 1, 4, 5, 1, again, if we see at each character, we have a choice whether we can remove it on the spot, we can remove it then and there on the spot. And second choice is we can keep it for our future use. Right, this we can do as we saw here in this, and here also we saw, right, that what we do, that what we have did, right. So let's suppose here 1, 4, 5, 1, 3, 1 is given. What we did, we have, we like didn't remove this one. Instead, we kept it. Maybe in the future it can get combined with this one, right? So this two will combine and will make 1 1, and it may possible this 2 1 again will combine with this one, and again they can make 1 1. So obviously when we are combining the same character, then our length is increasing, right? So what we are doing here, 1 4 5 1 3 1. So what we did, every character we have a two choice. We can remove it on the spot. If we can like remove it, then it will be simply contribute 1 square length. Second, we will not remove it immediately. Instead, we will kept it for our future use. It is possible then that in future we may encounter some similar character and both length will combine. If we see here for this example 1 4 5 1 3 1 1, what we're actually doing, we are for each character we are finding whether there exists a similar character in the future, right? So we can merge them. That's what we are doing. For example, this is one element. For example, this is L. So for this one, we will find whether a similar character exists in the future, right? So we will get this element K and we will try to merge them in one. So before merging them, we will have to remove these boxes, right? Then only we can merge them. That's what we can do. So the sum of, so we need to find the sum, I mean what the cost is required to remove these boxes for these boxes. So the cost of removing these boxes will be K minus 1. Then this will be merged in one. Again, same approach. We will try to find for each character whether there exists any future similar character, right? Because see, if we remove each number individually, then we will be getting only one square. But if we merge them and then we remove them, then obviously our length will increase. Like in this case, if we remove this one, like here only, we will get one square. But if we remove this first 4 5, then this will be something like 1 1, so it will be 2 square. Similarly, we will find for all the matching case, right? What I'm saying, for example, this 1 4 5 1 is there, 3 is there, 7 is there, 1 8, right? So if we remove this 4 5, then this 1 will become 1, so length will be something like 2, right? But if we see, first we remove this, then there can be another probability, then 1 can also here, right? So in that case we need to remove this, right? This can also be a case. So for each character we will try to find any matching character in the future. So we will try to merge the current character and that matching character in one, so we can maximize our length and fun, and we can maximize our score also. So what we see, 1 4 5 1311. So if we take this as L, so we will try to find the matching character with this, right? So we will check by iterating one by one whether any character matches. For example, here this character matches. This will be first match. So we will try to remove this first so that we can merge them both together. This will be the first. Next match will be, if we see 1 4 5 1 3 1 1, next match will be this. For this cell, this scale, next match will be this. So in the next match, what we will try to remove this one 4 5 1 3, right? And what will happen of this, for example, after matching, after like matching, we will get this. So we need to solve, now we need to solve for this. So again the same approach that we will use, take this as L. Again for this we will try to find any matching character. For example, this example would be something like this one. It will be something like 1 4 5, and 4 will be there, 7 will be there, 1 3 and 1 1. So we'll start from here, L, we find one matching character, right? So we will now try to merge this in one, so our string will become this 4547. Now again this will be our L. Now again we will try to same approach for this also. Either we can remove this boxes one by one. So if we remove this one by one, then 1 square 1 square 1 square 1 square. Second, what will be, we will not remove it like immediately, and we will try to find some matching character. So for this fourth matching character will be this, right? Again we will try to same approach, we will try to merge them both, so our sum for this will be maximized, right? One sum we will got, we have gotten from this, so it will be 4, one score. Another score that we can do, that we can merge them, this 4 and 4 both. So for that merging we need to remove this 5. So by removing this 5 we get 1 square, and if we, what will the remaining string we get, 447, right? So now what is the length we are getting, we are getting 2 square, right? And plus this 7 1 square, so this will be 6, right? If we are removing this 4 5 4 7 1 by 1, then we are getting 4, but if we try to find any matching character in the future, then we will getting 6. So if we see 1 4 5 4 7 1 3 1 1, so from, by removing these boxes, the max that we get is 6, right? And now what will be, now since we have removed these boxes, now it will be 1 3 1 1. Now again same approach, already we have gotten 6. Now whether we can remove this one on the spot, these two, or we can kept it for our future use, right? If we remove this on the spot, then it will be 2 square, plus till now the sum is 6, so it will be 10. Till now, I mean this one, like still 3 1 1 are remaining, this part is still remaining. But if we keep this for our future use, then it may possible that we may again encounter any future one, like in the future. So again if we see, we have encounter 1 k, so now this is L, this is L, and see this L is carrying this extra one with him, right? This is from the past, he is carrying this one extra one. If you see character, and we have removed this 4547, right? So our string became 11311, and our L moved to this, right? And if you see, this L is carrying one extra one with it, right? So how we can track this, how much this L is carrying, I mean how much extra character this L is carrying with him. So we will need one another state, we can say, to track this. So that state we can as F or X or anything, right? So again for this L we will try to match that whether any character we have found matching. So if we see this we have found, this will be K. Again we will try to remove in boxes in between. So now it will be 1 1. So for this, like how much we will get? We will get 1, right? So we will get 1. Again, this will be like this. Now our uh, uh, L move, if you see, this one is carrying 2 extra 1 with him, right? See, we are like every time we have some carry that will keep on getting increases every time. So now again this L will try to match any matching character, so it will get this, right? So it will be 1 1 1 1, and now I'll move here, and now if we see, this one is carrying 3 extra 1 with him, so 3, right? So now if we try to remove this boxes, so what will be the score? Length of this one 1 plus length of these 3 3, this will be square, and how much it will be 16, right? Which is obviously much greater than if we try to remove them individually. If we try to remove them like individually, then 1 1 1 1 1 1 1, right? That we gotten 2 3 4 5 6 7 8. This part itself is getting more. Remember one thing, that every time we are carrying some extra character, that extra character with it, right? If we saw here, this one is carrying 2 extra character. Here if L is here, this is carrying 1 extra character, and this is carrying 3 extra characters, right? This is carrying 1, this is carrying 2 extra character, and this is carrying 3 extra character. So for tracking this character only, we will introduce one more state that we can name it X, F, or anything, something like this. So like initially our states were L, R, but for this problem our state will be L, R, and X. X is the carry that we are doing. 1 1, and suppose here 5 7 also there. So this will be L, this will be R. Suppose we started matching which match, like which character matches with our L. We find this K, right? And we know this one is going with this one for calculation. So we will solve for this L plus 1 to K minus 1, and plus, since this one is going with this one, so this one will carry one extra one, right? So this will be K, this will be R, and we will introduce one variable X plus 1 with this, right? And in the this will be our first option. Second, it may possible for this case only 1 4 5 1 3 1 5 7. K can here be also, right? K can here be also. So for this we will find, and for this we will find, and this one will go with this one as a carry. Again for this, for L plus 1 to K minus 1, this again will be a new string, right? I mean, this again will be a new character set of characters. So again for this we will find with the same, this will be L, this will be R, again same approach, right? So isn't it like something like a recursive function we are doing the same work again and again with the smaller subparts of the problem, right? So 4 5 1 3 1 5 7. So when this is L, this is, sorry, this is R, we are matching. First match found is here, so we solve for this recursively. We solve for L plus 1 to K minus 1, and then this one will get carry with this one, right? That's what we are doing. Suppose 1 4 5 1 3 is there, we are trying, since we know, like if we do, like if we remove one by one boxes, then the cost will be low, obviously it will be this. But anyhow, if we remove this two, if we remove this two, then obviously this will combine to something like this, then this two will have a greater effect, or the greater cost will then compared to the single one, right? If they are if they are contributing like individually. So that what we are doing here. Now here, from here it will be k to r, and one extra one we are carrying for this k. And again we will solve for this recursively, and again we will solve for this recursively. So what this will be, l plus 1 k minus 1. Now our function will solve for this, and now from here k, and here like obviously there is no extra carry, so it's is 0. And for here it will be from 1 3 1 5 7. Wait, now we will solve for this recursively. Again this will be l, again this will be r. So again we will try to match it. Here we found k, right? So again this will, if we now again write it, then it will be, for this we will solve. So this will go here, and this will carry with this one. So what it will be, it will be 1 5 7 plus one extra one that is carrying. So here it was x, now it is carrying x plus 2, something like this, right? Now again we will solve for this string 157. So like this we are seeing, we are solving it like recursively again and again. So again this, if we see, this will be l and this will be r. Now again we will try to match, we will not found like any matching character. Then we will move to our default approach. Default approach was there, we will go one by one. Like we will try to remove the boxes one by one. 1 square plus 5 square plus 7 square. Sorry, 1 square, 1 square. Right, so 1 square, if we see here, we are carrying this x plus 2 means, for this character means this one has come till now this much times, right? So what we will do, x plus 2 already there, plus 1 y1, because this one will also contribute. What this x plus 2 means, before this one already x plus 2 times 1 had already come. So here x plus 2 is equal to 2, since if we see twice has come, right? So it will contribute 2 plus 1 square, plus individually they will contribute 1 square plus 1 square. So it will be around 11. If we list down our approaches, one for this only, 1 4 5 1 3 1 5 7, 1 4 5 1 3 1 5 7. At each index has two choices. Either we remove it on the spot, or second, we will keep it for our future, so that it may possible that in future it may contribute to the bigger score than it is contributing now, if we are removing it now single-handedly. Like if we see here, if we remove this one on the spot, then it will contribute only one, right? But in the future, if we remove this one, then it will combine with this one. Then in that case, it will be 1 1 3 5 1 5 7. Again, here we have a choice. We can like remove it on the spot, this 2 1, or we will store it. If we will remove it on the spot, then it will contribute around 2 square, right? But if we keep it, then after removing this 3, it will contribute 1 1 1 5 7. So now it is contributing 3 square, right? So that's if we write the algo for this. So our will be 1 4 1 5 7 1 3 1 2, something like this. I mean, it can be. So this will be L and this will be R, right? We will try to match with all 1, so first k will be here, first match will be here. So I mean, we will try to match for all possible case. So first k will be here, second k can match here, and third k will be here, right? So each k will contribute as a different path, and we will find the maximum of all those possibilities of k. So what will be our logic for this? So suppose our solve function is something like this: L R X is the carrying, that extra carrying that we are doing, that we have discussed. So if L equal R, then we will return something like this: x plus 1, y x plus 1. See, x is the carrying that we are doing for L, right? That we have discussed. So as we have discussed earlier, here this is x, right? This is what we are carrying. This is x, this is x, this 2 is x. So oh, this will be return x plus 1 into x plus 1, right? And if L is greater than R, then we will return 0, simply 0, then we will return. Now one approach that we have discussed is we can simply remove boxes one by one. So in that case, what will be our cost? So if suppose in that case cost will be again x plus 1 into x plus 1. See, 1 is for this cell, right? For example, 1 4 5 7, we are removing this box, then it will be 1. And with this one we are also carrying some extra 1, right? It might possible that we may carry some extra x. So we are doing x plus 1 into x plus 1 plus solve for L plus 1 R and 0. And next will be we will match for all. Let's put this is k is less than equal to R, and k plus plus we will match. Suppose s is our string, s is s caret L equal s dot caret k. And then what we will do, we will divide as we have discussed what we are doing. Suppose this is 1 4 1 7 5, this is our k, this will be our matching point, this will be L, and this will be R. So this will be this, again we will solve like this we will solve recursively. So what it will be, solve L plus 1 k minus 1 and 0, right? Since here there is a no carry, since this one is getting carried with this one, right? For this part from here, for like in this recursive function, this one is getting carried, not in this. So 0 plus solve now k to R, and this, since this one is getting carried, so we will do x plus 1 carry we will add, and this will give us one cost. Suppose this is temp. Right now we will since there can be multiple case, so we need to find the max. So we'll find all the possibilities. So we will do mat dot max of all the such possibilities, temp max, right? And when we come out of the for loop, one cost is calculated by this approach, and one we have calculated from here, right? So we will find the max of both. 10 temp, sorry, max, this will be max last. So if we go to the coding part of this, As we can see here, when there is only one boxes, when L equal to R, then we are simply doing F is the carry that we are doing. We are returning F plus 1 into cross F plus 1. And if greater than R, then we will return 0 simply. This is our default approach on this part. Like we are removing boxes one by one. We are not keeping that particular box for our future use. So we will simply remove it. And in the and here we are checking in that to remove our feature box, we are forming the pair basically. And at the end we are storing it in DP and we are returning it.